friends, so today we are beginning with the first lesson of the subject physics of 11th standard, which is units and measurements. It is basically divided into 5 parts, but I'll begin with the first and the basic part. So let us begin with the concept chart, which is of physical quantities. So basically it tells us that physical quantities are divided into 3 parts. First one is fundamental, which is the most basic one. Second one is derived, which is a bit advanced, and third one is supplementary, which is the most advanced. So for now we'll talk about the fundamental and derived. Supplementary we'll talk afterwards. So fundamental quantities do not need any units to explain themselves, means they are self-sufficient and they do not need any units to explain themselves. Second one is derived physical quantities need some of the units to explain themselves, and not all. They are also a bit self-sufficient, but still they need help of some of the physical quantities to explain their use and their role in physics. So now we are going to see we are going to talk about fundamental physical quantities, which is the most basic one. And let us begin. So guys, we get to see that there are 3 types of fundamental quantities. First is degree Celsius, second one is degree Fahrenheit, and third one is degree Kelvin. So I'm sure you would have heard about Celsius and Fahrenheit, but few of you would only have heard about Kelvin. So let us understand them better. So friends, in all the above 3 mentioned quantities, there's a note which says that in all the 3 units mentioned, degree Celsius is considered to be more convenient. In everyday life you would be using degree Celsius many times as compared to degree Fahrenheit and degree Kelvin. So let us understand their correlation between each other. So friends, 0 degree Celsius is equal to 273 Kelvin, which means that 0 Kelvin equals to minus 273 degrees Celsius. And also there's a point to be noted that 0 Kelvin is also known as absolute zero, which means that all the matter are not able to move at 0 Kelvin, which is the least temperature recorded yet. And there's some scientific convention which says that at 0 Kelvin any plasma or any membrane does not move, and it also freezes. That's why 0 Kelvin is said to be absolute zero. So friends, now let us see a few units and the way they are expressed and their symbols. So first of all we have length, which is expressed in meter and its symbol is m. Second one we have mass, it is represented by kilogram and its symbol is kg. Third one is time, and it is represented by second or minute or anything you can say, and its symbol is S. So now we have a note with us which says that these are regarded as fundamental quantities as given by the SI system. SI means System International System, which is a French form. So we can select any set of quantities as fundamental quantities provided they are not independent. There are 11 unindependent fundamental quantities. They have a huge list, but we have taken just 3 as they are the most common ones, and therefore we can take any of the 11 and consider them to be fundamental quantities. Now next we have a question with us which says that which of the following cannot enter into the list of fundamental quantities in any system of units. See, I have not given you the options. I have directly told you the answer, that is length, time and velocity. The reason I have also written that it says that since they are not independent, hence these cannot enter into the list of fundamental quantities in any system of units. See, above only I had told you that this fundamental quantities which are independent can only enter the list of fundamental quantities, and henceforth since the length, time and velocity are unindependent, therefore they cannot enter the list of fundamental quantities. So now let us study the special case, which is the supplementary quantities. There are 2 types of supplementary quantities. First one is plane angle and second one is solid angle. plane angle has a unit which is radian, and solid angle has a unit which is steradian. You can also call it steradian, but since it's E, that's why I'm calling it steradian. The symbol of radian, you can see alpha, beta, y, theta, and also ohm. And in steradian we have W and an ohm. We'll see the definition of supplementary quantities. Supplementary quantities are geometric quantities of circle and sphere. Supplementary are the units not still classified either as base or derived, which means that all the supplementary quantities are geometric quantities of circle and sphere, means they are derived either from circle or from sphere, as we can see that alpha, beta, which relates to circle, etc. And supplementary are the units not still classified either as base or derived, means you cannot classify these quantities into either as base or as derived. Hope you would have understood. So for now, our next concept is dimensions. Dimensions, we'll study a few points about it, which is in all system of units, the derived physical quantities can be expressed in terms of mass, length and time raised to some power, which says that if we have to find the dimension of any physical quantity, we can express them in terms of their mass, length and time, which are raised to some power. We are going to solve some questions related to this dimensions in the next part of the video. So we'll take now the next point, which is the powers to which fundamental units must be raised in order to express a derived quantity are called as dimensions. Means in the next part, when we'll solve the questions related to dimensions, we'll get to know about the powers of these mass, length and time, and from that how can you find the dimension of a specific physical quantity. So do watch the next part, as it is very important for all of you. Now we'll see in which two parts is the dimension classified. So dimension is mainly classified into two parts. First one is unit and the second one is formula. Its units are also very important, and so is the formula. In this session, I will not take all the questions of dimension, but let us take for an example, just let us take an question related to dimension, which is that find the dimension of velocity. So now, since we have to find the dimension of velocity, so we'll write its formula. As we all know, velocity equals to displacement upon time. You would have learned this formula in 9th or 10th standard both. So displacement is nothing but length and time is nothing but time. So what we'll get is 1 L raised to 1, which is single unit of length and a single unit of time. Now what we had learned a few seconds earlier, that we have to express them in three units: mass, length and time. So since we have got just mass and time, we haven't got we have got just length and time, and we have not got mass. So what we'll write is dimension of velocity. We write dimension of velocity in such a way, we will write velocity and put them in two brackets. So dimension of velocity is equal to m0 L1, and since t is 1 upon t1, so we'll write it t raised to -1. So now friends, that's all for this lecture. In the next part, we'll solve the questions related to dimensions, and we'll find the dimension of different types of units, and also understand how can we find them, and the different formulas which we have to use, and the different concepts which we have to use in order to find the dimensions. So thanks for watching. Stay tuned, and do like the video, share with your family and friends, and also subscribe the channel. Thank you and bye bye.